Okay. I didn't record our first day, the first meeting that we had. So let's do a re-record, which is okay because we'll probably have this will probably be a lot better quality than from Zoom. So that's okay. Not a big deal there. Need to start the slideshow. That'd be a good idea. There we go. Okay. So we're going to talk about the class, central tendency and variation. So we've been to two classes, so some of the stuff you already know. We haven't been to in-person one, so if you weren't there the first day, this might be something you want to take a look at. But if you were there the first day, you can probably jump ahead. So this is a little bit of a different setup of class than you've probably had before. For one thing, it's a flipped classroom. So what you're going to do is you're going to look at the lectures ahead of time, right? So that's kind of like your Tuesday. You can think of it like a Tuesday-Thursday class, except that on Tuesday, you don't come to class. You're just watching all the things and doing all the activities that are on the Canvas site. So everything is done in that flipped classroom style. Like all the lectures and some of the practice is done at home. And then when we come together on Thursday, we discuss things. You're going to ask me questions, and then I'll explain things a little bit, and then we'll also do some practicing. It's also a hybrid class, right? Which means half of it is done online. That's all that Tuesday stuff is done online, and then our Thursday is together in class or on Zoom. And then lastly, it's a sync class, but we've been doing sync for a couple semesters now, so you get sync. You can attend virtually through Zoom if you like. You can come to class if you like. You can sometimes come to class and sometimes attend virtually, whatever. If you want to treat it like an online class and just only come through Zoom, it's totally fine. I know some of you have even asked me about that already. Some of you are in Phoenix. Some of you are in... somebody's in another state, I believe, and that's totally fine. A lot of our stuff is going to end up being done in breakout rooms anyway, just because of we can't get close to each other. So even if we're in person, we can't really work in small groups in the way that we used to. So, we'll just have to make do with the way that it is. All right, so if you are coming in person, of course, you have to take your drink and put gum in your mouth before you come to class, because you have to wear your mask at all times in the classroom. And then definitely leave space between the other people that you're sitting with. This, again, is that small group problem that we have issues with. That you'll have to just use a Zoom breakout room instead of working in, like right together, huddled together in a small group. So leave space unless you live together, unless you're roommates or something like that. Oh yeah, and don't wear tuxedo shirts, right, because they're tacky. Yes, I forgot that I had that joke in there. All right, cool. All right, some basic things about Excel. This is where you should definitely watch. Well, if you were there the first day, you probably got all this also. So if you weren't there and you watched the other, you definitely need to watch this too. The analysis tool pack is definitely also tool pack. It doesn't have a C in it, so that's a typo. The analysis tool pack is one of the biggest things that we're going to be working with. If you have a PC or a Mac, either a desktop or a laptop, you should be fine. Analysis tool pack is something that you can get. If you unfortunately are using a Chromebook or an iPad or anything else, then you don't have analysis tool pack. Here's the thing. If most of the time our lectures, the pre-recorded lectures that we have, they will give you the code that you need to complete these things. Sometimes when we get further into the class, it might just be something that you do with the tool pack. I'm writing a textbook right now that is giving all of the code for Sheets and Excel if you don't have tool pack. So I can provide that to you. So you can probably make do without a machine that uses ToolPak. But here's the caveat to the caveat, which is if you're not super comfortable with Excel code, it is going to be a little bit more difficult for you. So if you are comfortable with Excel code, if Excel is something that you've used and you don't have the ToolPak, you probably can make do with the code that I'm going to give you. If you don't have the ToolPak and you're not new, like totally new to Excel, or just not comfortable with it, it might make sense for you to do your work somewhere else. What I mean by that is you could go to the Computing Commons, you could use a friend's computer or a parent or a sibling or something like that. You could use their computer, borrow one from somebody if they've got the ToolPak. So there's a lot of options for you if you don't have a computer that uses ToolPak. You could not use it. You could try to find somebody else's. But anyway, I'll give you that code. And if you think it's working for you, then that's cool. And if it's not, you can decide at whatever point that you need to make a change. Okay, so some Excel basics. The equal sign is your friend. Everything starts with an equal sign if it's a mathematical operation. If you don't put an equal sign in and you type in a mathematical operation, you're just going to get that operation as like a cell entry. It thinks it's text. If you put an equal sign, it does not think it's text. It actually thinks it's something that it needs to be doing. So if you want to say 1 plus 1, you need to have an equal sign, and it'll give you 2. If you don't have an equal sign, it's just going to say 1 plus 1. If you want to say square root, you have to say equal sign, SQRT, parentheses, 9, parentheses, and it's going to return a 3. If you want to add 2 cells together, you have to say equal sign, B2, plus E4 or something like that. And it'll give you the sum of what's in B2 and E4, right? Okay. Excel, by the way, kind of works like a bingo board. Like none of us are 80, so I don't know if we really understand how bingo works. But I'm including myself in that. Like I've seen people with the markers, and I know that sometimes there's neon, and they're like, it's bingo night. But anyway, I've never, like, my exposure to bingo was in grade school, and you'd get, you know, like math bingo or something like that. Anyway, presumably there are BINGO across the top, and you come down, and so you have bingo and numbers along the side, right? So you'd go like B4 is the fourth square down from the B, and I1 is the first square down from the I, and O3 is the third square down from the O, and that's how Excel works. It's got A, B, C, D, E, F, G, all the way to like ZZZ, I think, along the top, and then just an ungodly amount of numbers going down, like 1 through, I think, over 100,000. I don't know how far it goes. 999,000? Could be. I'm not sure. I've never gotten to the end of Excel, but I've tried. Anyway, so cell A2 is going to be the first column and the second cell down. B4 is going to be the second column and the fourth cell down. So it just works like that. Okay. So parentheses are also a must. We know that the equal sign is really important, but also parentheses are super important. Any function that you're using starts with parentheses. So remember I said if you want to do the square root of 9, you're going to type in equal sign SQRT parentheses 9 parentheses. Those parentheses tell Excel that it's taking the square root of whatever's in the parentheses. And you can't just leave them off. Even if it's a single number, you still have to have the parentheses. It makes the function work. That's true for anything. That's true for average. It's true for standard deviation. It's true for everything, right? You always have to have the parentheses. Parentheses, parentheses, parentheses. Parentheses. Must. Always have them. And when in doubt, throw some parentheses in. So if you don't know if your like number and then the caret, the little caret 2, which would be like something squared, if you don't know that Excel is going to treat that as the first thing that it does, because you know it goes like parentheses, exponent, blah blah blah, please excuse my dear Aunt Sally, PEMDAS kind of thing. Excel does work that way, but if you want to be extra sure and you want to put parentheses around all the different operations, you absolutely can. It'll color code them for you. So you'll have green and then red and then blue and then black, and then when you're closing them, you'll get the corresponding color. And you just go and it'll highlight it too, so it'll make them bold as you get there. So you can see that you have the right number of closed parentheses and as open parentheses, and see that you're not making an error anywhere. So that's nice. Anyway, if you're never sure that you need parentheses, it doesn't hurt to throw them in. Excel will work with it correctly. Okay, let's there we go. Let's talk about Kindy. We're going to take a little detour here and talk about this guy right here. This is probably at least somewhat what he looked like, although they did not have cameras in the 800s. This is not 1800s. I didn't make a mistake. It's 800s. Super long time ago. Kindy was a totally cool dude. I mean, in addition to this awesome shirt that he's wearing, he was also a musician, a philosopher, a mathematician, other things, a poet, a polymath, which just means a lot, you know, good in a lot of different subjects. All sorts of things. Really a lot of stuff. Historian, I think. Pretty much everything. You name it. Kindy's done. One of these things that's important is this mathematician part. I mean, the musician part's pretty cool too, but for our purposes, the mathematician part is pretty interesting. Kindy is the first recorded person, I should say, to use central tendency to solve a problem. And the central tendency, and the problem that he solved with central tendency was, someone asked him, how many bricks do you think were used in the construction of that castle, that fortress? And he said, well, I don't know, but I think we can figure it out if we look at a little area. So you kind of looked at this area right here, and then this area. And these are like supposed to be the same size, right? I mean, I don't know what they used in the 800s in the Ottoman Empire to measure things. Maybe a cubit. I don't know. I don't know what a cubit is. Presumably it's not a cube. Maybe it's, let's just say it's feet. You know, it's probably not feet. Let's just go with feet. So they look at like a 3 foot by 3 foot square, and they count how many bricks are in it. They choose another spot on the castle, another 3 foot by 3 foot square. How many bricks are in that? Another 3 foot by 3 foot square. How many bricks are in that one? And they average those together. When they average those together, then they figure out like how many of these 3 foot by 3 foot squares would be in this entire castle, and then multiply that by the average number of bricks in the different not cubes, the different squares that they've counted up, and that gave them a number of how many bricks were, should have been used to construct this castle. Now here's the thing, the bricks at the time weren't necessarily always very uniform. They're pretty good. I mean, you could still use wooden forms, but occasionally they'd get smushed or something like that. Sometimes they'd use rocks. And it was like 17 bricks off, I think, around there, maybe 57, something like that. It's some number that's like really small, considering they're counting up the number of bricks in an entire fortress. And to be off by that much is essentially a rounding error with the number of bricks that they're talking about. So really spot on guess of how many bricks were used to build this fortress. And it was all done with central tendency. Pretty cool. So anyway, Kindy, first person, first recorded person to use central tendency to solve a problem. And then he probably like wrote a song about it or something afterward. I don't know. All right, so let's ourselves do some central tendencying. The first one that we want to do is the mean. The mean is your typical, average. When we say like, well, take an average, that's the mean. The formula for this, what you're going to do is you're going to sum all of your x values, your observation values. That's what x is. Actually, it should be x sub I is really what you should be seeing. So you should have, where's my cursor? You should have a little I right here. There we go. So x sub I just denotes numbers in this array. That's it. So every x in this array that we've termed I, whatever, the array is all of these. That's a pretty, I don't know. It's a pretty deep mathematical concept to think of all of these as different arrays. And maybe at some point we'll talk about different arrays and why you would number them different things or label them slightly differently. But anyway, each x value is just one observation. So x1 is 19, x2 is 20, and so on. So the first thing that you want to do to take the mean is you want to sum all of your x values. This is sigma right here. This is the Greek letter sigma, and that just means sum. Some sigma. So you sum them up, add them up, 241. Here's the actual formula for mean. It is the sum of every x. Again, this should have a tiny little I next to it. The sum of every xi over n. You want to divide by n. So you add all of these values together, divide by the number of values that you've added together. That's what n is. And in this case, n is 14. And so when we add all these up, it's 241, and we'll divide it by 14, which is our n, and the answer that we come up with is 17.21. I don't have my tech assist today, so I had to pre-compute all this. But thanks for looking out on that first day of class. Okay, so what about the median and mode? Well, to find the median, what we need to do is we have to rewrite our numbers in, I was going to say chronological order. That's totally not the right word. We're going to rewrite our numbers in numerical order, right? So we're going to go from smallest to largest. You could do largest to smallest. It doesn't matter. And what you're going to do is you're just going to find the middle number. So the way that I do this is I think of the n, and I divide it by 2. 14 divided by 2 is 7. And so I'm just going to count 7 from each end, right? So we'll go 1, 2, 3, 4, 5, 6, 7. And now we're going to start at the other end. 1, 2, 3, 4, 5, 6, 7. Well, shit. We have a problem, right? We ended with 17 and 19. We counted 7 from one end, we counted 7 from the other, and now we have a 17 and 19. We don't know what the middle number is because there's 2 of them. Well, that's not true. This happens when you have an even numbered data set. All you do is you take the average of those 2 numbers, and that's your median. And so the average of 17 and 19 is 18. And so 18 is our median. No issue. It's all cool. Now what happens, what I've done here is I've deleted the 21. See that down at the bottom? what happens if you have an odd number of values? Now we have 13 numbers. 13 divided in half is 6.5. That rounds up to 7. And so I'm still going to count 7 from either end. 1, 2, 3, 4, 5, 6, 7. And now we're going to move down to the bottom. 1, 2, 3, 4, 5, 6, 7. Ah, so we've counted one number twice. That's the middle number, 17. So for this set of numbers, the middle number is 17. For the previous set of numbers, it was 18. And this one, we have 2 arrows pointing at the same number, so we know that's the middle number. For the other one, we had 2 middle numbers. We had to take the average of those. Not a big, not too hard, right? It's okay. Oh yeah, there's the middle number. Okay. So what about the mode? Well, the mode, you just count up what number occurs most often. And in this data set, it's 19. 19 occurs 4 times. Everything else occurs either once or twice, but not 4 times. So 19 is definitely the mode. Okay, well that was mean, median, and mode. That wasn't too bad, right? But now let's talk about variance and standard deviation. This might be a little bit harder, but you know, it's not too bad. I think you'll be just fine. Go ahead and follow along though with a calculator if you want to. And you can pause me when as necessary. These are the same numbers. So we know that the mean, which I've got here as the mean or x bar. Sometimes you'll see it as x bar. A bar just denotes a mean, and x, again, like you know, is the values in that array. We could throw an I in there, again, to denote which array we're talking about. Here's the thing. When you're only dealing with one array, it's okay not to have a sub I. We can talk about just x, and it's okay. When you have more than one array, then you should start denoting. If you're talking about the average of I or the average of j or whatever. Okay, so the mean here is still 17.21. The formula that we want to use for variance is this one right here. Variance is also known as s squared. And the formula is, here's our sum again, the sigma, which is a Greek letter. So you're taking the sum of, and then we've got in parentheses, each observation minus x bar, which we said was the mean. So we're going to take every observation minus the mean and square it, and then take the sum of all those, and then put it all over n minus 1. Okay. We are assuming that this is a sample because most of the things that you guys are ever going to deal with are samples. In actual statistics, we really only deal with samples. I don't think I've ever done statistics for a population. So, you know, that's the nature of the thing right there. You're just always dealing with samples. If you were dealing with a population, you'd write these things a little bit differently. So instead of s squared, it would be this little omega squared. And instead of n, it would just be capital N. No minus 1. So this whole phrase right here, n minus 1, would just be n. That's for a population. You'll almost never have a population. You probably won't have a population. So your formula for variance is almost always going to be all of this over n minus 1. And your symbol for variance is almost always going to be s squared. Okay, so the first step is this stuff in the inside, right here. We need to do every observation minus x bar, which is 17.21. And so you can see over here on the left, that's exactly what we have. 19 minus 17.21, 20 minus 17.21, and so on. And so what are the answers to that? Here they are. 19 minus 17.21 is 1.79, and then you get all these numbers all the way down. One way to check that you have the right answer, that you've subtracted these correctly, is to add all these up. So you do 1.79 plus 2.79 minus 1.21 plus 1.79, and all the way down. It should be 0. It should be 0 because the average is the middle value of all of these numbers. And so if you add these all up, it should be a 0, or very, 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 very close. In fact, if you add all these together, you end up with 0.06. So there's a little bit of error in there somewhere, but it's 0.06. And so that tells me I did compute all of these differences correctly. Okay, so that's this middle part here. We find all the differences. Now the next part is we square them. And that's not hard either, right? So we just square all these. So 1.79 becomes 3.20. Negative 4.21 becomes positive 17.72, because anytime you have a negative and you square it, it becomes a positive. So then we have all these values that, of course, are not going to add up to just 0. So what we want to do is this part. We want to add them all. And these come to 100.3. The next step is that we want to divide by n minus 1. Our n is 14, so our n minus 1 is going to be 13. We have 100.3 divided by 13. I should have a line between those two, but I don't. Just pretend that there's a line between 100.3 and 13. But 100.3 and 13, 100.3 divided by 13 is 7.72. And that is our variance. The variance is 7.72. Not really that hard. What about standard deviation? Well, the formula for standard deviation that you can see here is S equals the square root of the sum of every x value minus the average of x squared over n minus 1. Well, this probably looks really familiar, right? This formula right here is the variance formula. It's the same thing. So another way you could write the formula for standard deviation is the square root of s squared, the square root of variance. And so if you do that, you take the square root of the variance. The variance, of course, is 7.72. And you take the square root of it, you get 2.28. So that means the standard deviation is 2.28. What does that mean? That means that you can expect the mean, which is 17.21, to vary by about 2.28 numbers. I mean, I don't know what units we're talking about here. I just made these numbers up. So I don't really have a unit. But anyway, the average, a number in this number group is going to often be within one standard deviation of the mean. So the mean is 17.21. To find the bounds of one standard deviation, you just subtract 2.28 from 17.2 from the mean, and you'd also add 2.28 to the mean. So we'd get about 15, slightly less than 15. Just kind of doing it in my head. So we'd get slightly less than 15 to 19.5 or something like that, right? And that's where most of our values lie. Somewhere between 15.2 and 19.5. And that's true. Most of these do fall in there. We've got a couple 13s that don't. We've got a couple 20s and 21s that don't. but beyond that, everything does actually fit in there. Okay, well, we'll talk about standard deviations more later in the semester, and what one standard deviation versus 2 versus 3 translates to in mathematical terms. But basically know that this is how much you can expect a value to change from the mean. Like any observed value, how much difference would you expect there to be from the mean is what this is telling you. All right, so we looked at mean, median, and mode. Not too difficult. We looked at variance and standard deviation. Maybe a little bit more difficult, but still not too bad. I think, yeah, that's the end of the video here. So hopefully that was helpful, and I'll see you later this week.